Ninth grade honors scholars, welcome, welcome. Conservation of Energy Lab. We are going to be looking at the fact that whatever energy you start with, that should be the energy that you finish with. And when you have a system, you're assuming that there's no friction in the system and energy is not going to be lost. And so that's our assumption. However, in the real world, friction does cause energy to be lost out of a system. So now in this lab, we are going to be taking a tennis ball, and here it is, a handy dandy tennis ball. And then you can see over on the wall, here's a meter stick right here, and right up there is our 2 meter mark. I'm going to drop the tennis ball from 2 meters, and I will supply you with the amount of time that it takes. Actually, when we're in school, the students actually have a way of finding this out. I'll talk about that when I give you the data. And then, maybe I should do it that way. We're going to figure that out on our own. And I will give you the data on that. But then the other thing that happens is we'll measure the bounce height for the 2 bounces. So, here we go. This is going to be quite exciting. I guarantee it, it'll be quite exciting. So here we are. Here is the tennis ball at 2 meters, and it is just out of the screen. And now we drop it, and then we can see that it has a couple different bounce heights. Wow, there's the lab. You do that 3 more trials, and you are done. So now, here's what we're going to do. Let's get to the lab by clicking here, and there we go. There's the lab. Here's what you need to know about the mass of the tennis ball. It is 0.05 kilograms. 0.05 kilograms. Get that in there. Now, here's what I want you to do. I'm going to put you in breakout rooms, and I want you to determine how much time it takes the ball to drop 2 meters. And we know how to do this. We've got equations that we can figure this out with. Because whenever an object drops, it's accelerating downward due to gravity. And so we have to use that time is, well, I'm going to let you figure out what equation to use. So right now I'm going to pause, and I'm going to be setting you up in breakout rooms, and then we'll come back and I will give you the rest of the data. All right, you determined in your groups that the amount of time that it takes to drop is 0.64 seconds. You use the equation time is a square root of 2d divided by g. And then here is our first bounce height. Actually, the tennis ball I used, I noticed that it went above 100 centimeters, but here's the data that I'm going to give you. 0.95 centimeters, or meters I should say, and finally 0.48 meters. So there's all your data. Now all you get to do for the rest of the time here is calculate the velocity of the ball. Actually, just do our data analysis questions. The really important questions are going to be question 2 and question 3, and 2, 3, and 4, because they're going to be looking at the potential energy as I'm holding the ball at 2 meters. We'll have the kinetic energy at the bottom just before it hits the ground, and then we're just going to compare them. And question number 4. So question 2, 3, and 4 are the important questions. The rest of them are questions to do, but 2, 3, and 4 are the basic, very important questions. All right, that's all I got for you. I will see you later.